Alright, so in this problem, I have 500 to the power of 500 divided by 250 to the power of 250. So, to solve this, what I'm first going to do is rewrite this as 500 to the power of 250 plus 250 over 250 to the power of 250. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 500 to the power of 250 plus 250 is going to equal 500 to the power of 250 times 500 to the power of 250. And I have all of this over 250 to the power of 250. Now this is the same thing as 500 to the power of 250 times 500 to the power of 250 over 250 to the power of 250. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 500 to the power of 250 over 250 to the power of 250, and I can rewrite that as 500 over 250 to the power of 250. Now, this is equal to 500 to the power of 250 times 2 to the power of 250. And if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So in this case, a is 500, b is 2, and of course, m is 250. So I get 500 times 2 to the power of 250, which is equal to 1000 to the power of 250. And this is the same thing as 10 to the power of 750. Alright, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not, because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula, because this is not a quadratic equation. So to solve this, what I want to do is rewrite this as x to the power of 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4, and the reason I did this is because negative 16 is the same thing as negative 2 to the power of 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4's together and the powers of 2 together. So I get x to the power of 4 minus 2 to the power of 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power of 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power of 4 minus 4 squared. and I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4 by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So actually at the start what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive negative square root of 5i.